Hey, a few of you have asked me, how do I figure out which side of the graph should be shaded? So, with an inequality in particular. So, I have a very simple trick for you. And here it is. You want to pick a test point. And by a test point, you want to pick some point some XY point that you can put the XY values into the inequality and see if that point, those X and Y values, continue to keep the inequality true. If they do, that point is on the side of the inequality that will be shaded because it is a member of all of the possible choices that would make that inequality true. On the other hand, if it is does not make it true, then that point and every single point on the same side of the boundary line of your inequality will not make the inequality true. So none of them get invited to the party, and only the other side is shaded. So I'm going to demonstrate this for you with a couple of inequalities. I've got y is greater than or equal to 2/3 x minus 5. So I'll go ahead and plot a couple of points. I know that I'm going to have a y-intercept at -5 for my boundary line. My boundary line will be solid because it's or equal to. And I can take this other point and I can move over here to this point, and I'll use my 2/3 slope. So up 2/3. And then I just need to move that boundary line into position. So, oops, that's the wrong thing I'm grabbing. There we go. Floop, move it around again, floopity floop. Okay, and slide it down like that. So it's roughly right there. That's a little better. Okay, so now I've got my boundary line almost lined up. Yeah, that's better. Now I got to figure out which side is going to be shaded. Okay, the easiest point you could possibly pick to plug into this inequality is the point 0, 0. So test 0, 0. If 0, 0 makes this inequality true, then everything on the 0, 0 side makes this inequality true. So you'd shade that side. So we're going to replace y with 0, and then we'll replace x with 0. 2/3 times 0 minus 5. And then we work this out. Okay, 2/3 times 0 is just 0, so I'm left with just minus 5. 0 is indeed greater than -5, so everything on this side is going to end up being shaded. So here I'll just grab a scribble, and I'll just scribble around here. Blah, blah, blah. Great. That side is shaded, and so that side wins because 0, 0 is on the winning side that makes the inequality true. And any point on this side, you could test this out of this if this is sus to you. You can pick any point on this side and test it out. But 0, 0, I promise you, will be the easiest one for you to work with. Okay, let me undo my scribbliness. Okay, and I'll get rid of that. And then we're going to go back over here and we'll test this other equation out. So this other equation, I'm going to have an x-intercept at -8. So let's move that over here, -8. X-intercept will be -8 because -24 divided by 3 is -8. And I'll have a y-intercept at +3 because -24 divided by -8 is +3. So there's my y-intercept. This is not an or equal to inequality, so my boundary line is going to be dashed because it doesn't get invited to the party. And so I'll bring this up here and I will swivel it around to get it lined up better. Actually, pretty good like that. Okay, and I'll bring it down, and there we go. Now we got to figure out which side is shaded. Well, the easiest point again is 0, 0. As long as it doesn't go through 0, 0, use 0, 0. If it does go through 0, 1, 0 or 0, 1 will be options, and those are pretty easy to do calculations with. So I'm going to use the point 0, 0. So I'm going to copy pasta this, and I'm going to replace x and y with 0. Okay, so y became 0 and x becomes 0. So now I have 3 times 0 minus 8 times 0, which is just a whole lot of 0. 0 minus 0 is 0. And so 0 is greater than negative 24. So 0, 0 wins. So 0, 0 is on the winning side. And once again, I grab my scribbly thing and I'll scribble on the winning side because 0, 0 is the winner. So that is the side that will be shaded. And every point on this side will be a solution for this inequality. The line itself will not be because it's not or equal to, but you can get as close as you want on this side and it'll work. Any point on this side will fail. Now, if you don't want to use 0, 0, you don't have to. Use some point that's definitely going to be on one side or the other. Test it out. Okay, and if it succeeds, if it makes it true, the side that point is on is the shaded side. If that point makes the inequality false, okay, I'll give an example. If I change this to positive 24, and we go ahead and regraph this point ends up over here at 8, 0, and this point ends up down here at 0, negative 3, and we bring this down. It conveniently lines up again just fine. Okay, a little bit of adjustment needed, but the slopes were the same. And so now I'm going to test 0, 0 out again with this new inequality. Okay, so I made a little change. Okay, I copy pasta it. I'll replace that with 0. I'll replace that with y got replaced with 0. Now x gets replaced with 0. So I've got 3 times 0 minus 8 times 0, which is a whole lot of 0 minus 0, which is a whole bunch of 0, or nothing. And now it says 0 is greater than 24. Is that true? No, it's not. 0 is not greater than 24. So 0, 0 is a big fat fail. And so 0, 0 does not get invited to the party. It's very sad over here. But everyone over here is just going, yeah, we're partying over here. So this side of the graph is the shaded side. Okay. And I hope that cleared that up for you. Just as simple as picking a test point. And if you're going to have to pick a test point, pick something that's easy. Don't pick 9.7823, 5.7382. Yeah, pick something easy like 0, 0. That'll do the job.